All right, so today we are going to start reviewing for test 4. We'll actually get through almost all of it. And just have a couple left for next class. Okay, number 1. Y equals 1/6 to the x power. What I would recommend is just going to your y equals and putting that in. So you have 1/6. You're going to raise that to the x power. So once you graph it, since this is multiple choice, you'll be able to see which one it is. Okay, let's plot a few points on this though by going to second table to see why it is what it is. I'll start with that -2 point. So making a table. So let's see why this graph takes the shape that it does. All right, starting with this -2. So to the left 2, and then up 36. So it's going to be left 2 and then way up, even off that wall. This point to the left 1, up 1, 2, 3, 4, 5, 6. Left and right 0, up 1, so it's going to cross the y-axis at 1. And then once it crosses the y-axis and I'm going to the right, it's just getting closer and closer to that x-axis. So this one says to the right 1, up 0.16667. So barely up at all. And then look what happens when you go to the right 2. It goes up even less. Okay, so again, it's just coming right down here next to. It doesn't cross the x-axis. It just comes right up next to it. So number 2. So we're still in exponential graphs, but this is one of those where it's going to have the shifting rules. So you've got f of x equals 2 to the x plus 5. So this one's going to be multiple choice, and it's going to, every single one's going to start off the same. It's going to say start off with the graph of blank to the x, which you'll put in the 2. The multiple choice part has to do with this shifting. This is an inside number, right? If it's inside the exponent, that's an inside number, which will shift it left and right, opposite the sign. So you're going to start with the graph of y equals 2 to the x power, and you choose the one that says shift left 5. Now, remember the tricky part on the graphing in this section. The first thing you'll do is choose the exponential shape in your toolbox. And then click anywhere on the graph, and it's going to put that exponential shape right there at the origin. Then you're going to have to come down to the shifting box and do this horizontal shift. Shift it to the left 5. And also remember down here in the shifting box, the default setting is for the base to be E. So you're actually going to have to go in here and delete that E out and replace it with what your base is, which is 2. Number 3 is another one of these. F of x equals 2 to the x plus 5 again, but then minus 2. So this one says you're going to start off with, good, 2 as your base to the x power. Where are you shifting it 5 units? The 5 is in the inside shift. So you're going, again, left 5. The 2 is an outside number. It's outside of the exponent, which means it shifts up and down, go with the sign. So where are you going to? Down. So again, when you go into graph, again, you'll choose the exponential shape. You'll make your 2 shifts. You'll shift it left 5 units and then do your vertical shift and shift it down 2 units. And once again, you need to make sure that that base is set to 2 instead of E to graph it. Right, number 4. All right, here's the formula for number 4. Now, remember, we had 2 different kinds of formulas when we were talking about compounding. If it's compounded quarterly or semi-annually, you're going to use this formula and put the number of times it's compounded a year in the n spots. If it's compounded continuously, which we did later, that's when we use the formula that had the E in it. Okay, so this one says, suppose that $64,000 is invested at 5.5% interest, compounded quarterly. So let's fill in. A of t equals, the P is your principal. That's what you're starting with, which is the 64,000. Open parentheses, 1 plus. Now, the R is going to be your interest rate, which is 5.5%, but we need to change that to a decimal. Let's see, 5.5 would be 5.5%. To change that to a decimal, I need to move this 2 places to the left. So now I have 0.055 over the N is the number of times it's compounded a year. Quarterly means it's compounded 4 times a year. So I'm going to have 4 in both of those spots and then T. So let's see what's in this parenthesis. A of t equals 64,000. Let's see, 1 plus 0.055 divided by 4. So again, I'm just simplifying what's in that parenthesis, which gives me 1.01375 to the 4t power. So this is what's going to be the answer to the first part of this question. It's going to ask you what A of t equals. Then it's going to say the amount of money in the account at t equals 0 years is blank. So the only thing that you are changing from here on out is what is in place of the t. So when t equals 0, you're finding A of 0. So you're replacing the t with a 0, and then you're just putting that in your calculator, okay? If you've only put the money in and it's been in there 0 amount of time, it's still going to be 64,000, right? Because this right here, if your exponent is 0, you'll have 64,000 times 1.01375. 4 times 0 is 0. But what is anything to the 0 power? Not 0, 1, right? This will be 1. So you have 64,000 times 1, which is still going to leave you with 64,000. The next part says the amount of money in the account at t equals 2. So it's been in there 2 years. So the only thing that's changing is this part of the exponent right here where the t is. So that's 2, which changes the exponent now to be 4 times 2, which is 8. And then you'll just put that in your calculator. So 64,000, open 1.01375, close, and then go up into your exponent, and your exponent's 8. And we are rounding all of these to the nearest dollar. So the first number after the decimal is a 2, so I don't need to round up. So it's 71,388. And it says t equals 5. So 5 years. So again, all you're changing is what's in the exponent. So now it's 4 times 5 in your exponent, which means now your exponent is 20. So 64,000. Open 1.01375, close, and go up in your exponent and put 20. And round it to the nearest dollar. So you have 84,100. The number after the decimal is a 2, so I don't need to round up. All right, there is one more part to this question, but it's just still doing the same thing over and over. It says t equals 10. So you would just put 10 in both of those spots and make your exponent 4 times 10, which is 40, and put that in your calculator. All right, the next question is still going to be using the same formula. Suppose that, oh no, on Melissa's 6th birthday, she gets a $2,000 CD that earns 6% interest, compounded semi-annually. If the CD matures on her 15th birthday, how much money would be available? So let's see, what's the principal? How much is she starting with? 2,000. 1 plus, my interest rate is 6%, which would be 0.06. What's the N? It's compounded semi-annually, which means twice a year. And I do know the T. It doesn't tell me the number of years, but she got it on her 6th. It matured on her 15th. So how many years has she had it? Not 7. 9. I can't subtract very good in my head either. So let's see, 2000. You put this 1 plus 0.06 over 2 in your calculator, you'll have 1.03 to the 18th power. And this one wants me to round it to the nearest cent. So you always got to be careful and make sure you are looking at how it wants you to round it. That last problem wanted you to round it to the nearest dollar of all this. This one wants you to round it to the nearest cent. So 2000 open, 1.03 close to the 18th power, rounding to the nearest cent. After that 86 is another 6. So you're going to round this to 87 cents. So $3,404.87. Number 6, getting into the log stuff. Find the logarithm, log base 10 of 0.1. Now remember, you do have a log base button function in your calculator. If you just hit the math button, and then scroll down to A. There's your log base. So you'll just put the 10 here, arrow over, and put the 0.1 there. Which tells you -1 would be that logarithm, right? Because 10 needs to be raised to the -1 power in order to be 1/10. So -1 is that logarithm. Number 7. Log base 6 of 6 to the 3rd. So remember, when you're finding the logarithm, you're saying what power does this base need to be raised to in order to be what's in this position? So what does 6 need to be raised to be 6 to the 3rd power? It needs to be raised to the 3rd power. Or you could think of this as also saying log base 6. 6 to the 3rd power is 216. So 6 needs to be raised to the 3rd power to be 216. You can think of it either way. You can type that in the calculator. Did you put this 3rd power?
I did it outside of the
Do it. Do log base 6, and then in that, put it inside the parentheses, 6 to the 3rd. Number 8. Let's see if you want to put this one in log base. Math button. Down to A for log base. In my base, I'm putting 256, arrow over, put 4 in parentheses. It's going to tell me 0.25, but the answer is going to say type it in as a fraction. So if you're not sure, just math, enter that to turn that 0.5 into 1/4. Number 9. Find the logarithm. Log base 37 of 1. What do you need to raise 37 to in order for it to equal 1? 0 power, right? Anything to the 0 power is equal to 1. So if this is a 1 right here, doesn't even matter what this is. You would have to raise it to the 0 power to equal 1. All right, 10 and 11, we are going to be given an exponential equation and asked to turn it into the logarithmic equation. Convert to a log equation. 10 to the 3rd power equals 1,000. So let's see, 10 to the 3rd power, if I'm going to change that to a log, the base of your exponent is also going to be the base of your logarithm. Then these two are going to switch sides of the equal sign. So log base 10 of 1,000 equals 3. Same thing on number 11, convert to a logarithm. E to the 4th power equals m. So I'm converting to a log equation. What is this log? What's the base of it going to be? E. The base of the exponent is the base of the log. Switch places of m equals 4. So you could type this or what is also called log base e. You could do ln of m equals 4. Either way. Right? Now we're going to go the other way. It's going to give us a log equation and ask us to convert it to the exponential equation. So log base 5 of 625 equals 4. So if I'm going to turn this into an exponential equation, again, the base of the exponent is the same thing as the base of the log. So I'm going to have 5 to the 4th power, and that's going to be equal to what's in this position, which is 625. Same thing. Log base p of m equals -z. And remember, these are case sensitive. So the p and the z are lowercase and that m is capital. So I'm going to have p to the -z power is going to be equal to m. All right. Number 14 says, use a calculator to find the natural logarithm. So this is just a calculator work. You have ln of 541.6. So it's just, and it's going to say round to 4 decimal places. So just hit the ln button. 541.6. Close, enter, and round it to 4 decimal places. So 1, 2, 3, 4. After that 5 is a 2, which just means I don't need to round up. So I just have 6.2945. Number 15 says, find the logarithm using the change of base formula. Log base 7 of 13. Now you can go in your math button, go down to log base and just type this in. Okay, the change of base formula says I can rewrite this as log of 13 divided by log of 7. To get the same thing I would get if I typed in log base 7 of 13. And again, round to 4 decimal places. So log 13 close divided by log 7 close. Go to 4 decimals. So 1, 2, 3, 4. After that 1 is a 2. So again, I don't need to round up. So I have 1.3181. Rewrite or express as a sum of logarithms. So remember, if this is a multiplication in here, I can rewrite this as 2 logs added together, both log base 10. So I'll have log base 10 of 10 plus log base 10 of 100. Log 10 plus log 100. Yeah, but you don't need to even solve it. It just wants you to rewrite it. But yeah, because this 10 times 100 is 1,000, right? So 10 to the 3rd power is 1,000. This is what? 1, right? 10 to the 1st power is 10. So that's 1. 10 to what power is 100? 2. And 1 plus 2 is 3, which is the same thing as log base 10 of 1,000. Okay, but all it wants you to do in this one is rewrite it as the sum. Okay, number 17. Express as a product. I've got log base m of y to the 6th power. So if I'm expressing this as a product, I'm going to have something times something. That's what means express as a product. This exponent does what? Comes down and it's times the logarithm. So you have 6 log base m of y. Number 18. Rewrite as the sum of logarithms. You've got log base c of x to the 6th, y to the 3rd, z. So I'm going to rewrite this as the sum, since those are multiplied. So I'm going to have log base c of x to the 6th plus log base c of y to the 3rd plus log base c of z, and then bring down those exponents. So I'll have 6 log base c of x plus bring down this exponent. So 3 log base c of y plus log base c of z. Number 19. Express as the sums and differences of logarithms. I've got log base b of p squared q to the 6th over m to the 5th b to the 8th. So I'm expressing as sums and differences. The ones that are in the numerator are going to be the sums. Those are the ones that you're going to be adding. Once you get to the denominator, you're going to be subtracting these, and they're all going to be that log base b. So I'm going to have log base b of p squared plus log base b of q to the 6th. And now, since I'm moving to the denominator, now is when I'm going to start subtracting log base b of m to the 5th minus log base b of b to the 8th. Bring down my exponents. Now, this right here should trigger that that's a special kind of log, right? This right here means when I bring down my exponent, it's actually going to be the only thing I have, because it's going to be 8 times log base b of b is 1, right? What do you have to raise b to in order for it to be b? 1. So this whole thing turns to 1. So this very end is just going to be minus that 8. So let's see, I've got 2 log base b of p plus 6 log base b of q minus 5 log base b of m minus, like I said, that's just going to be minus 8 at the end there. Number 20. Simplify this expression. I've got ln of x squared plus 13x plus 30 minus ln of x plus 10. So if I am simplifying, the first thing I want to do is turn this into a single logarithm, which means since it's minus, what is it going to convert to? This one over this one. So I've got ln of x squared plus 13x plus 30 over x plus 10. Now, in this numerator, I need to see if that factors. Because if one of the factors is the x plus 10, it's going to have some canceling to do. So let's see, in the numerator, x and x for x squared. Factors of 30 that add to 13 are 10 and 3. So if that's over x plus 10, these x plus 10s cancel. So you're just left with ln of x plus 3. Same kind of problem. Log of x squared plus 3x plus 2 minus log of x squared minus 1. And again, express as a single log and then simplify. So since it's minus, I'm turning it to this one over this one again. So log of x squared plus 3x plus 2 over x squared minus 1. So again, I'm going to factor. So in the numerator, x and x for x squared. Factors of 2 that'll add to 3 will be a positive 2 and a positive 1. This denominator also factors. X squared minus 1 is a difference of perfect squares. So it's going to be x and x for x squared. And then how do you multiply to get 1? Right, you're going to have plus 1 and minus 1. The x plus 1s will cancel. So you're just going to be left with log of x plus 2 over x minus 1. So 22 is when we were getting into exponential equations, where we're solving equations where the x is in the exponent. Like number 22, you have 2 to the 8x equals 8. So the first thing you want to try is to see if you can rewrite this side to be a base of 2. So let's see what 2 does when you give it new or different exponents. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. So this is what I'm going to rewrite this side as, is 2 to the third power. So both sides will have base of 2. So if you can do that and make your bases the same, then you're just going to set up an equation with your exponents and solve it for x. So 8x equals 3. Divide by 8. So x equals 3/8. All right, number 23. Two to the x power equals 7. So I can't use that same method because 2 to the second is 4, 2 to the third is 8, which means I pass right over the 7. So now I have to figure out how I'm going to get that x out of the exponent. So we're going to use that rule of logs that says if you have a logarithm that has an exponent, you can rewrite it as that exponent times the log. So I'm just going to log both sides, right? Because whatever you do to one side, you have to do to the other. So now this will come down. So I have x times log 2 equals log 7. So now to get the x by itself, I just need to divide by log 2 and round it to 4 decimal places. So I just have log 7 close, divided by log 2 close, round it to 4 decimal places. So 1, 2, 3, 4. After that, 3 is a 5. So I will round that 3 up to a 4. So I have 2.4. 8074. $24. Solve for t. You got e to the negative 0.37t equals 0.70. So let's see. Here's what I'm solving for. It is in the exponent, which means I need to get it down. Since I'm dealing with e, instead of regular log both sides, what am I going to use? Natural log, or ln, both sides. That'll bring down my exponent. So I have negative 0.37t times ln of e equals ln of 0.70. So this ln of e, here's why we used ln, because what is ln of e equal to? 1. So you really just have negative 0.37t times 1. So to get this t by itself, I just need to divide by negative 0.37 for my t to be by itself. So I'll push this in my calculator, round it to 4 decimals. So I've got ln 0.70 close divided by negative 0.37. Round it to 4 decimals. So after that 9 is an 8, which means I do need to round up. So that 39 is going to round to 40. So I have 0.9640. All right, one more. This is the last exponential equation. $12 to the x equals 4 to the x plus 1. So the x that I'm solving for is in the exponent. So I am going to log both sides. It'll bring down the exponent. So I have x log 12. This brings down this exponent. So I have x plus 1, and I need it in parentheses, log 4. So both of these go to that log 4. So let's multiply what's in those parentheses times that log 4. X times log 4 will just be x log 4 plus 1 times log 4 is just log 4. Let's bring the left side down. X log 12. Now, my x is what I'm trying to get by itself. It's in 2 separate terms that are not like terms, so I can't put them together. But I do want them on the same side as each other, right? Because once I put them on the same side, I'll be able to pull the x out. So let's move this x over here with this one. So let's see, on the left, I've got x log 12 minus x log 4 equals, on the right side, I just have that log 4. And again, the reason you put this over here is because now the x is in common with both terms and you'll pull it out. And put in parentheses what's left. If I take the x out, I'm just left with log 12 minus log 4. Equals log 4. So to get this x by itself, I just need to divide by everything that's in this parenthesis. So log 12 minus log 4. Now, remember, you got to be careful when you're typing this one in. So these are going to cancel. That's going to be my x by itself. Now, over here, remember when you hit the word log, it automatically gives you a parenthesis, right? So it gives you that open. You're going to have to make sure that you close it around that 4. Now, when you're typing in the denominator so that all of this stays in the denominator, you're going to need to open a parenthesis before you start typing it in. So you'll have open and close around the 12, then open and close around the 4, and close again to close out that last part of the denominator. So you've got log 4, close, divided by, open, log 12, close, minus log 4, and then after the 4, you'll need to close and close again and round it to 4. So 1, 2, 3, 4. After the 8 is a 5, so I will round that up to a 9. So I've got 1.2619.